Hi, and welcome back to Red Siege's Shellcode Obfuscation series. In this installment, we'll be taking a look at something called Jargon. Jargon is a shellcode obfuscation routine that I came up with a couple of years ago that allows us to encode shellcode as dictionary words. We've written a lot about this. There have been talks recorded on it. We have webcasts on it. So I won't go into this in super deep detail. But know that you can find blogs on the Red Siege page. They're linked from the Jargon repository, which is github.com/Red Siege/Jargon. And there are also talks that have been out there where this has been explained, such as my role for stealth, intro to AV and EDR evasion talk. So let's take a look at the code and see how Jargon works. So to start out with, we've got a Python script that will run through our dictionary, run through our shellcode and encode it into dictionary words. So the reason we want to do dictionary words is because they lower entropy. If you don't know what entropy is a measure of the amount of randomness in something. And when we use encrypted shellcode, we increase the amount of randomness in our payload, which some EDR and AV engines will detect. So we can use Jargon to put shellcode in a shellcode loader without having any encrypted data, without having high entropy, and actually without having any shellcode in it at all. So this is Jargon. I'm not going to go through all the code here. Uh, but what I can tell you is that we are going to uh, create an array of words that we pull randomly from a dictionary. We're going to generate 256 unique words from our dictionary. And we're doing 256 because there are 256 possible shellcode values, 0x00 through 0xFF. Each word in our list of shellcode represents a unique byte of shellcode. And it would be easier if I show you the generated output. So let's take a look at that. So we've created something called a translation table here. So we have 0 in the first position, which is index 0 here. This is going to be music. So anywhere that 0x0 appears in our shellcode, we are going to put the word music in. Conversely, anywhere where FF appears, we're going to put visit. And then we're going to put, if it's FE, we're going to put arena. So this is our translated shellcode here. You can see that it starts out with the word spank. Now remember, our shellcode starts out with FC. So we have FF, FE, FD, FC. So right there, we looked up our shellcode value, which is FC, which is an integer 252. And then we read from position 252 in this array. We see that the word was spank. So we inserted spank into our translated shellcode array. Now we've got a bunch of words here. None of this is shellcode. Now, when we want to get it back to shellcode, we're going to have two loops. First, we're going to do a loop that is equal to the number of bytes of our shellcode. And then we're going to loop through our translation table. Our translation table contains 256 entries. So we're going to iterate from 0 to 255. And we're going to do a string comparison. We're going to take a look at the word that is in the translation table index. So the first time we go through, it's 0. And we see if that word is equal to the translated shellcode variable at index SC index. So if SC index is 0, meaning it's our first word in the shellcode array, we're going to be looking at spank. And we're going to then look at index 0 in the translation table, which happens to be music. So that's not a match. We're going to increment our translation table index. We're going to take a look at taste, wings, audio, so on and so forth, all the way until we get to 252, which is going to be spank. When that happens, now we have a match. So we're going to insert into our shellcode array at our current shellcode index, which remember, this is the first loop. It's going to be 0 and it's going to be equal to the index value that we're currently at for our translation table. Our index value is 252, so we're going to insert 252 into our shellcode array. And we're going to continue this process until we've looped through all of the bytes of the translated shellcode. So let's take a look at how or if it does work. So when we run it, we get FC4883E4 ending with FFD5, exactly like we thought would happen. When we scan it with Defender, we don't see any detections. So we'll upload it to VirusTotal. And we can see it was only detected by 4 engines. So this is a vast improvement over some of the techniques that we've taken a look at. This also gives us low entropy. So we don't have nearly as much entropy in there as we would with a totally encrypted shellcode type of payload. We can take a look at virus total, and that'll tell us some of that information. Like we can see the amount of entropy in the sections and try to figure out like how much of this is encrypted data, how much isn't encrypted data. And if we compared this against, for instance, our AES loader, we would see that the entropy would be lower. So there you have it. That is Jargon. Now you know how Jargon works, and you can find it on our GitHub repository if you want to check it out. So, with that, that'll end this installment. Stay tuned for the next time where we're going to take a look at a puzzle. Thanks.